At the mill again. So just a very quick explanation of what we're doing here. So here I've got the two blanks for the two halves of the feed screw nut. On this side, which is the side nearest to the operating handle, there are going to be two holes. The one here will be for a 1/4 inch UNC tapped hole. One in the middle, which will be a 3/16 reamed hole to take a form of dowel pin, and over the back here will be another 1/4 inch UNC tapped hole. I've set this up using the centre finder, and I've measured that, so I know that is 0.1187 in radius. So I've brought it up against there, put -1187, done the same on this side. Now I have marked this out using my centre height gauge, and I've dropped the hole smack in on the marks, so I'm quite pleased about that. So I'm just going to drill a hole. What I've done here is I've got the depth stop set on the mill head. I've taken the drill down to full depth when it hits the depth stop and locked it off. I've then brought the table up, zeroed it at that point, and I've just brought it up 0.89 inches, so that I now know that when I drill down, when I get to the depth stop, I'll have 0.89 of an inch hole in there, which will be exactly what I want to then tap. I'm waiting for a plug tap to come. That will be Tuesday, and it's Friday early afternoon. So I'm just going to drill a couple of holes. I may, if I get a chance, tap this one. And theoretically I can go backwards and forwards, but I prefer to, having got the dimension in one plane, get it sorted, do the next one, and then move over to the far side and do that. So that's the way I'm going to work it. Well, I'm back at the lathe, and I've got my embryo feed screw nuts here ready to put on. The initial machine is complete. That section's in there, that's all drilled up, ready to fit on. Nice and central, so I'm happy with that. I was looking at doing this on the Myford, but the depth of the Myford jaws is such that I can't really get this in and hold it properly on the jaws. So I've decided to put it on the Colchester. And in order to do that, I need the Colchester running. And in order to do that, I've had to put the old nuts back in to enable me to make the new nuts. So it's going back together at the moment. Now the interesting thing is, as those of you that saw a previous video will note, if you will remember, I had play here, play just about everywhere. What I've done in reassembling it, I have put my new cross feed screw in, and I've tried a number of ways of fitting it, and I found one which is absolutely perfect. So I've marked it up so I get it in the same place every time. I've put the old feed screw nut in, but what I've found is with the new screw, and I've also fitted some new thrust bearings to the original specification for this. I could have got them about £5 cheaper by buying Chinese versions, but I thought let's get the FAGs that they were built with originally. And having put this back on, the amount of backlash I'm finding has dropped considerably. I'm still getting it, and it's still coming. It's coming from the place I identified rather earlier. If I look over here, I put that mark in there before, but if you look at the back of where that post goes up, you can see it just picking up at the back there. Yeah, you can see that just moving there, and that little bit of rock is what's taking up all of the backlash. The backlash in the feed screw is zero, effectively. I can't find any backlash. As soon as that stops moving, I'm getting movement in the cross slide. So I need to make the new feed screw nut. Yes, I could go with the one that's in there now, but I know that's badly worn, so I'll make a new feed screw nut to go in there. I also got a new dowel to go in there which locates it properly, and that's in there on this version. So I need to get that in the chuck, get that centered, bore out to 0.510, and then put my tap through, which is there, and I know that that works because that's what cleaned up the nuts that are underneath. So I'm really pleased with what I've done so far on this, and it's proven that my feed screw is fine, or the new feed screw is fine. It works with the old feed screw nut and has given me decent, almost zero backlash. So with the new nut I should improve on that, and it gives me then a lot more adjustment going forwards as it wears. So I'll get this on here, I'll get that in place, I'll drill and bore that out, and then I'll get that sorted. So this is the fun part. I've got the feed screw nut in the forejaw. I've got a centre in the centre drilled hole that will soon become a much larger hole, and then a screw thread, and I'm just holding it in the tail stock centre and trying to get the needle to stop moving. So that's our maximum left and maximum right, so that's about middle to be, so that needs to come this way a little bit. What was that? Oh. That was my glued joint letting go. Bugger. So that's going to come back and start again. So I've gone back to the sort of 1800s and I've soft soldered it. So I heated this up, flux paste on it, a little bit of solder, and then stuck the two halves together. So hopefully that will hold. So I stick that in there like that. I'm going to have to put together a backstop for this lathe, I think. So bring this back in. Well, that's less than half a thou out. So that should do. Just make sure that these are all nicely tabbed up. Okay. That will do quite nicely. we looking at? Let's That doesn't like that. Yeah, that definitely doesn't like that. Let's go for a slightly smaller drill. Let's go for an 8.8 mil. So it's 5 mil in. Right, let's set up with the boring bar and I'll bring you back once I've finished boring this out. It's due to go out to 0.520. 505. So another 15th out come out of that. One of the more useful bits of equipment I have, and I would really recommend it, is a holder for the micrometers. It does tend to make life an awful lot easier when you haven't got to balance three things in two hands. Right, let's see where we're going. 518. So I think I'm going to leave it at that. So it's 18 thou clearance. And I'm not going to manage to get just 2 thou out of that. I think even the spring pass is going to take that over. So, the next move. Put that back in there. Is going to be to put the tap in. So let's get this as far out of the way as I can. This is the toy from the previous video, so that will drop in there quite nicely. And I'm going to get some cutting fluid for this, and I shall have some hiding down here. Some Trefolex. We're starting to cut. I think I'm going to have to single point this at least part way through. Oh, that will be fun. I've ground up and set up here an internal threading Acme tool. I reground a high-speed steel Whitworth tool. So what I'm planning to do is to try and pick up the threads in here, and the way I've been doing it is getting that to where it needs to be, engaging the angest unit, which is there and putting it back against the lead screw, and then trying to make sure that I've got the tool in the right place by moving it into the groove I've already got, or the thread rather I've already got, by manipulating the top slide and cross slide. I've already worked out where it needs to be for safe, and I've also preset the 0 point on the DRO for when it's actually touching the inside bore. So the next little thing is to make sure that I've got this set so that the ingest unit cuts out as soon as the threading tool has got through the nut. And that's only going to give me about 1/8 of an inch before it hits the tool post. So I need to do a little bit of double checking, so I'm going to run this at 72 RPM and then just make sure that it does knock off when I want it to. And of course, ideally what you do is you'd adjust the position of the top slide so that you can get the tool to finish exactly where you want it to. But as I've got to use the top slide to line the tool up with the thread, I can't do that. So I'm just hoping and praying I've moved it the right distance. Right, let's have a look and see what happens here. That looks take this in really, really slow I know where I think the inside of the bore is, but I don't want to guess and hope, so I'm going to approach it slowly. I should be 30 thou off at the moment. I'm going in at 10 thou increments at the moment. I'll speed this up a bit now. I'm going to take that up to 175. I know it's going to stop. It's cutting thread all the way down. So let's see what happens here. Remember to put it into reverse. Okay, let's see where we're going, shall we? See how this fits in. Well, it's going a lot further than it was, but it's still not feeling decent. Now, back to where we were. Well, I'm going to crack on with this. I'll come back to you when I'm a bit further down the line. Okay. Well, that's the nut tapped out. I've taken it out quite a lot of the way with the single point threading tool because this that's great at cleaning threads out. There's a few errors in the way I've made it. As I was saying the last one, this tap that I made, a couple of errors on it. The main one is that that flute should be much deeper than that, which has made using it an absolute pain. But it forced me to screw cut, which is a better way of doing it in the first place anyway. And then it's gone down and cleaned up where I'd screw cut it. So that's that done. And that will go on that way. It goes through there. That's nice. That fits very nicely. You've got a very small bit of wriggle room there from where it usually sits, so that's going to, but there's almost no clearance, so that will sit in there very nicely. I've just got to cut the two slots now to take the adjusting wedges. So that's the two halves of my feed screw nut. I need to tap those out with a plug tap, which I now have. So I'll take them over to the bench vise and do that. And that will go in there. And then set it up on the, then I'll set it up on the mill and mill the two slots for the adjusting wedges. So see what we can do about that. I've just used my edge finder to align with the fixture on the vise. I'm now moving it in because I know the radius on that is 0.118. So if I take that in 0.118 and then zero that is now centered over there. And I've done a little bit of calculation which tells me that with the milling cutter I'm planning to use, which is a 7/32, because I haven't got anything an appropriate size. I've got a 5/16, which is the slot size, but I know that will always cut slightly over. So I'm going down a size to a rather nice 3 flute short series end mill, 3 flute cutter. And I've worked out that in order for that to cut down the far edge, I need to come into 0.2114, which is 0.1020 from the edge, plus the radius of the 7/32 cutter, which is 0.109. So I've now calculated I've got 2 runs to do at 0.2114 and 0.305, and that will then take me to give me a slot that is 5/16 rather in width, I think. I've also marked the back here where the bottom of the slot will start, and then I can take it down to that level. So it's going to need a few cuts. I'm not going to rush it. This stuff is not the nicest stuff to machine. It's not unpleasant, but it has its little foibles. It's a very good bearing material. So cut that one down. The other one is exactly the same, but because I can't guarantee that it'll hold properly, I can't do two at once. I just need to set that one up at the same angle, and I'm using the Wixie gauge at 30 degrees. So I'm just going to put the cutter in there, move it to the appropriate position, and start milling the slot. .32 to 5/16. Well, that's the first one done. 3125 across there. I'll rub a very fine file down there just to make sure it's nice and smooth so that everything can slide. But that's the first one done. The second one is just exactly the same, so I won't bother to show that. Just got to set that up 30 degrees on the Wixie, down on the two parallels, and then I'll have the same depth set anyway, so I'm quite pleased with that. Right, I'll come back to you later. So we've got our 2 blocks there, milled with the slots on opposing sides, so they will fit like that under the cross slide. This one goes at the outboard end, that on the inboard end, so that has a locating peg and a 1/4 inch UNC, and that's just 1/4 inch UNC, and those are the 2 slots to take the adjusting wedges. Right, bit of cleaning up, get rid of some of the edges that are on there at the moment, and then that will be ready to have a go at fitting. I'm not too worried because I'm running the lathe at the moment with the old feed screw nut, and that is pretty reasonable. But if I can fit the new one in, get that done, and then I've got all the dimensions here if I need to make any more, or if anyone else wants to make one, I can let you have the sketch that I've done with all the dimensions on it. Right, let's go and get a cup of tea. It's that time of day. New lead screw nuts. I'm keeping the old wedges. So here are my original lead screw nuts, and this is the original lead screw that goes on like so. And as you can see, the play on it is, it spins on and it rocks, and they're the old ones. But now sitting here, I have got a new one. And that goes on and it spins with a flick, but it doesn't run and it doesn't wobble. And that one goes on and joins it. And those are my 2 new lead screw nuts. So the next job is to fit those into here. I'm going to move them quite a long way down. This is the long bit, so I'll get that down. Get those a good distance down. I've adjusted the angle and the depth of it so that I can just about fit the adjuster plate on the top, so it's back to what I would view as the maximum. So that goes on there, and if I turn that around, so that is black mark at the top and that to there, and that goes in. And if I hold that and turn this, goes there. Because these are, please be accurate now, that will just drop in like that. And that will drop in like that. And then that just sits in there quite nicely. That's just under flush with the top, which is exactly where I want it to be. I'm going to put these on in a minute. I've done a little bit of scraping. I'm not good at it, but I blued it and checked it. There was a little bit of wear, so I've taken most of that out. So I'm now ready to put that back together. I'm going to do a little bit of scraping on the jib strip because it seems to have a slight hollow in the middle here against the side. So I'm going to give that a very quick scrape that down, and that should be that. So I'll put this back together, get the top slide back on. Then the next job is going to be doing some work on the pivot block that goes on the back here, and that sits there, and that then just slides through. So that's good. The only thing that's not good about it is the fact that it's got a little bit too much slide play. So I'll have to work out a good way of dealing with that issue. I don't know what it's going to be at the moment, but we'll work that one out. So that's the new feed screw. That's the new feed screw nuts. New bearings went in. Before I finish fitting this, I'll grease them up. This is just a rough assembly at the moment. And the last thing is going to be, I think, I'm going to have to bore that out by about 1/8 of an inch and put an 1/8 of an inch sleeve in there, so that I can sleeve it down so that the pivot point actually can't rock. And if I can do that, I think that will get it probably as good as I'm going to.